ಹಲೋ ನಮಸ್ತೆ ಸ್ಟೂಡೆಂಟ್ಸ್. ನಾವು ಇವತ್ತು ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಆಫ್ ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಲ್ಯಾಮಿನಾ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಳೋಣ. ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಲ್ಯಾಮಿನಾ ಅಂತಂದರೆ ಯಾವುದು? ಸೊ ನೀವು ಯೂಶ್ವಲ್ ಆಗಿ ಸ್ಕೇಲ್, ಈ ಥರ ಬಾರ್ಸ್ ಅಥವಾ ಶೀಟ್ಸ್ ನೋಡಿದ್ದೀರಲ್ಲ, ಅದನ್ನು ನಾವು ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಲ್ಯಾಮಿನಾ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಅದಕ್ಕೆ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಹೇಗೆ ಆ್ಯಕ್ಟ್ ಆಗುತ್ತೆ, ಏನು ವೇರಿ ಆಗುತ್ತೆ, ಯಾವ್ಯಾವ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಬರುತ್ತೆ ಅನ್ನೋದನ್ನು ನೋಡೋಣ. ಸೊ ಅಬೌಟ್ ಆನ್ ಆಕ್ಸಸ್, ನಾನಿಲ್ಲಿ ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಲ್ಯಾಮಿನಾಗೆ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಹೆಂಗೆ ಕಂಡುಹಿಡಿಬೇಕು ಅಂದ್ಕೊಂಡಿದ್ದೀನಿ ಅಂದರೆ, ಅಬೌಟ್ ಆನ್ ಆಕ್ಸಸ್ ಪಾಸಿಂಗ್ ಥ್ರೂ ಇಟ್ಸ್ ಸೆಂಟರ್, ರೈಟ್? ಸೊ ಸ್ಕೇಲ್ಗೆ ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಲ್ಯಾಮಿನಾ ಅಂದರೆ ಒನ್ ಸೈಡ್ ಆಫ್ ಸ್ಕೇಲ್ಗೆ ಒನ್ ಸೈಡ್ಗೆ ರೊಟೇಷ್ನಲ್ ಆಕ್ಸಸ್ ಪಾಸ್ ಆಗೋ ರೀತಿ ಇರಬೇಕು. ಆ ರೀತಿ ನಾನು ಲೈನ್ನ ಡ್ರಾ ಮಾಡಿದ್ದೀನಿ. ಈ ಫಿಗರಲ್ಲಿ ನೀವು ನೋಡ್ಬೋದು. ಸೊ ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಲ್ಯಾಮಿನಾ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಿ, ಅದರದ್ದು ಲೆಂತ್ ಬೋತ್ ದ ಸೈಡು L/2 L/2 ಅಂದರೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಸೆಂಟ್ರಿಂದ ಪಾಸ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಹೌದಾ? ಸೊ ಹಿಯರ್ A.B.Sc and D is the rectangular lamina and the length of this lamina is L and the breadth of the lamina is B. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಇನ್ನೊಂದು ನಾನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಿ. ಆ ಯೆಲ್ಲೋ ಶೇಡೆಡ್ ಪಾರ್ಟ್ ಏನು ತೋರಿಸ್ತಾ ಇದ್ದೀನಲ್ಲ, ಅದು ಬಂದ್ಬಿಟ್ಟು ಎಲಿಮೆಂಟ್. ಸೊ ಸ್ಮಾಲ್ ಎಲಿಮೆಂಟ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಅದರದ್ದು ಡಿಸ್ಟೆನ್ಸ್ ಬಂದ್ಬಿಟ್ಟು ಎಕ್ಸ್ ಇದೆ. ಇಲ್ಲಿ ರೊಟೇಷನಲ್ ಆಕ್ಸಿಸ್ ಇಂದ ಎಲಿಮೆಂಟ್ಗೆ ಇರೋ ಡಿಸ್ಟೆನ್ಸ್ ಎಕ್ಸ್. ಓಕೆ, ಸೊ ನಾವು thickness of that element I have taken as a dx. Okay, so now we have to find out what moment of inertia for this element, not whole lamina. Now I am considering for the moment of inertia for this element, not whole lamina. Clear? So now this rotational axis what I am showing, that is xy is the rotational axis, breadth is b, right? So and the length of the lamina is L. So that is the element I am shown in a yellow color. Dx is the thickness and x is the distance from the rotational axis to the element. So now I am considering, therefore, rho is equals to, that is the density of the lamina, that is mass of that lamina divided by length, linear density. Similarly, the density for the element is what? Mass of that element divided by thickness of that element, that is m/dx. That is capital M, this is small m. Understood? So now anyway the density, linear density, whether it is a small mass, whether it is a bigger mass or any, for the given material density is same. So therefore rho is equals to rho dash. So similarly, therefore we will write it m/L equal to m/dx. Got it? So similarly, therefore mass of the element is equal to small m equal to capital M, that is the mass of the rectangular lamina, L and dx. Got it? Small m is equals to capital M/L into dx. So now by definition of moment of inertia, what it says, moment of inertia, that we know I is equals to product of mass into square of distance from the rotational axis to the mass of that particle or an object, right? So that is I is equals to here m r square, general formula. For r is what? R is for total length of lamina. For total length of the lamina is, for the total length of the lamina, we are finding the moment of inertia. It is given as the rotational axis, which is passing from where? Exactly the center of the lamina. So therefore it is divided into as what? L/2, and the right side is also L/2. So therefore I am taking an integration for minus L/2 to plus L/2, right? So over the limits. So mass of that element, it is how much we got? m/L into dx. And the distance for this element is how much we have? X, right? The distance is x. So therefore I will substitute here in place of our x square. Got it? So now integrate this above equation. So if you integrate this above equation, you will get as here m/L is constant, right? Mass of the lamina and the length of the lamina is fixed. It is constant. So therefore m/L, take it outside, integration m/L integration minus L by 2 to plus L by 2 x square into dx, right? So therefore I equal to m by L over the limits. X square is x cube by 3. Integration x square is equals to x cube by 3. Using the formula of what? X to the power of n equal to x to the power of n plus 1 divided by n plus 1 formula integration. So therefore I is equals to, here I will substitute the place of x as minus L by 2 and plus L by 2. So after substituting upper and lower limits, what happens? M by L 3L, so over minus L cube, L by 2 whole cube minus of minus L by 2 whole cube, right? I'm substituting where s place of x, I'm substituting plus L by 2 and minus L by 2. I'm substituting upper and lower limits. So I equal to m by 3L, L cube by 2 and plus and that one will become as a plus L cube by 2, right? So now what happens? It is m by 3L to L cube by 8, right? 3L. So there it is of 3L into 8. 8 3s are 24. I have written there. So 2 ones are 2, 2 12s are. So how much I will get? M by 12. M L square by 12. So I is the moment of inertia of a rectangular lamina which is passing about an axis, right? Thank you friends. If you like my videos, please subscribe my channel for more B.Sc related videos. Thank you for watching. And if you want to understand any concept, please comment in the below comment section. I'll answer for those questions. Thank you.